Hope you can hear me well. But what I want to explain today is one of the search functions or behind the search functions of how to use if you are going to be. So let's say you have a huge amount of data and you need to be able to access all of it at the same time as find something specific and everything that's similar to that specific thing that you're trying to find, right? So what you would call it is the search based off of the nearest neighbor or the approximate nearest neighbor, or the KNN, so NN for nearest neighbor, and then the K would be the algebraic expression of the input of which the search would be for. So vector search uses vectors, which is basically a conversion of text or data, whether it's an image, but we'll use text as an example, through an algorithm into a list of numbers. Normally those numbers are decimal, and then those numbers are based off of a 3D space, and where it's placed in that 3D space. So this search, this way of searching is the newest or latest and fastest way to find data and similar data through three different ways. So you start with a cosine one, which is basically, and I'm going to explain with these writings, it's basically you start at 0 for two of these, so you start at a 0 point, and then it points to specific data. As an example, it's like I need to get to this specific data that's over here, but we first gonna look at the nearest one that we have. That's why it's called nearest neighbor. So it'll look at A, for example, and then it'll look at B, and it'll create a line or a link to B, and then what it would do to see how similar B is to A, if A is the answer, is it'll measure this degree of change. So let's say this is pointing up in the 3D space. You have to constantly remind yourself that you're in a 3D space. Let's say from this dot you are pointing up at A, and then directly 45 degrees, right? You point to B from that same plane line. Then that would basically be a 45 degree difference. So you would have a decimal difference 0.45, whereas this is where the K and N calculations come into play, because you're working with three simple similarity functions. So if you have C, and then let's say our first viewpoint was from 0 point to A, that's our starting point, and then we looked at B and how similar it is to A at 0.45 in the decimal, and then now we're looking at C. Now C is 90 degrees, which would then mean that it has a 0 point. Technically, it's difficult to explain this, and let's say we have D over here, which is opposite to our first look, where A is the answer, right? A is the answer. We have, that's the text we're looking for, but now we're looking for text similar to A. B is the closest with 0.45, and then okay, this is the answer, it's A, so we make that as 1. And if you ever search again and it looks from the point to A, that's always going to continuously equal to 1. So it's a 1 for 1, 0.45 similarity, it's a 0 similarity to 1, and then if it's in the opposite direction and it goes to D, and it's looking there, then that's a -1 similarity. So it's the least similar, pretty much 50% similar, but you wouldn't look at it. You would rather look at the nearest neighbor, which is B, 0.45, and then while all of this is happening in calculation, you can create filters in your search where it would only bring in data. Let's say there's one smaller, very close to 0, the 0 point, and it's C, D, E. And even though this is, let's say, 55 degrees from a 55 degrees, then your filter, if you create your filter to bring in all data that is more than 0, it would bring in E and B to A answer, but it wouldn't bring C and it wouldn't bring D, right? So that's gathering the data that's similar. Then we move on to the Euclidean, which is a bit different because, and a bit simpler you could say, because you actually start with 2 points instead of the 0 point, and then you measure the distance between A and B. And there's a lot of calculations because most data conversion, when you convert it to the vectors, is 0.5, 0.7 and 0.4 as an example in the 3D space. So you would measure this distance, and let's say that your 1A vector has 0.568 and its other values are 0.7. What you would do is, instead of subtracting from A, you would subtract from B. So 0.5 minus 0.123, and then you would say 0.4. This is just rough calculations. And then let's say it's 0.7 minus 0.6, 0.1, and then you square that. Once it's squared, for example, I believe I have it here somewhere when I did the calculation. Yeah, there we go. So let's say 0.4 is squared. I would go to 0.1. If 0.1, which is technically 0.09, is squared, then it's going to be 0.008. And then you add those two together, you'd have a around about 0.206. These are just dummy numbers, so don't mind that. Then you would square that 0.206 and get a 0.454. So that's the distance between A and B, right? So that's 0.4, very similar to that 0.4 that we just got here by the degree distance, right? And then similarly, if you are going to do the same, but let's start with A as the answer again, A to C, which is a bit further away, do the same exact, which would be A 0.5 and 0.7, and then C, let's say that if this is 0.1, this is 0. Further away, so closer to 0, remember. So let's say it's 0.001, and this is 0.6, so 0.2 or something like that, right? And then that would be closer to 1 in the final calculation. 0.007 equals roughly 0.0004, right, as an example. So that's further away because it has more zeros in it, and is closer to 0. And then similarly you can have this exact same thing, but it goes to a negative 1.5 calculation, so it wouldn't bring that, right? Then you have the dot product, which is a very interesting one also, because if you start at a 0 point again, let's say A is the answer, the text again, it's sort of a combination between Euclidean and cosine, because let's say you have that same A being 0.5 and 0.7. Then what you would do is you would move this distance line from the 0 point of A onto the distance line from the 0 point to the vector of B. So you'd move this entire line and have it be on this B line. So let's say then that's this distance with these calculations, this distance right here, 0.454. Let's say that's 0.454, and then that would be on top of B, and then B's distance, if B's distance is further away, and let's say that's the 0.002, because it's further away from the 0 point to A, then you would, I believe, I forgot if it's subtract or add, but that would pretty much be, what is this? Is it subtract or add? I believe it's subtract. So you'd subtract those numbers and get a much further distance. So even though this is 0.002 further away, that wouldn't reduce much from the 0.452. So it's still quite close, 0.45. But let's say you would have C being much further away, off of the plane even, in the 3D space. Then you would create that line from the 0 point to C, and then do that exact same, move the A line onto C. Let's say this is, okay, I'm losing myself here, but in any case, that's the similarity. You create this A line onto each line, do the calculations like that based on length. Yeah, now I'm lost, but in any case, it's fun to get lost, you know.